Okay, live. So, good morning. Thank you, Iris, for introduction and giving an overview to Knx Rf. Welcome, ladies and gentlemen, to a presentation about Knx and Knx Rf Development with solutions from our company. It's Weinzierl Engineering. So I just have to share my screen. This is now. No, I'm sorry. Currently, I cannot see how to share the screen. No. Sorry for delay. Maybe I need some help. At the beginning, I had a few buttons. Oh, it was just out of the screen. Here it is. So I hope now it looks much better. Yes. So again, and again, let's start with an overview about Knx Rf Development with Vancil Solutions. I want to give you a short overview about our company, what we are doing, and of course, a short overview about Knx Rf aspects, and of course, also with Knx Rf together with ETS, and some development related solutions like our Knx BIOS modules, which are available as well for Knx Rf, and of course, the Knx stack. In our company, we call it the Knx stack NGS. And at the end, I would like to give you a short demo with our software tool, Net and Node. Our company, meanwhile, is more than 20 years active in the Knx world. So indeed, I could not really even remember a project which was not even related to Knx. We are located in the southeast of Germany, southeast of Bavaria, very close to the border to Austria. Indeed, only 500 meters are missing to our neighbors in Austria. And our focus, of course, is Knx, and we provide system solutions for the Knx standard. In the development point of view, this means, of course, Knx stacks and modules, but also we invest a lot of Knx development tools, which helps to implement Knx solutions quite rapidly. Of course, if you're doing technical development, testing is very important. In Knx, we have a dedicated certification scheme, and that's why in our company, we also have our internal Knx test lab. So we can do for our customers and of course also for our products, testing of Knx applications as well as Knx stacks. And also we provide a portfolio of Knx devices where we offer mainly system components, but also push buttons and actuators to our customers with our brand as well as many OEM products. So let's start with a view to Knx Rf. Knx Rf, meanwhile, has already a history of 20 years. Maybe you are surprised about this, but it started already in the year 2002, where the medium Knx Rf has been specified, and this specification still is alive. But at the beginning, Knx Rf was mainly intended to be used in the context of easy mode. That means it was not integrated into ETS. There was some push button mode and some controller mode, but the main problem was only a few manufacturers followed this idea. And meanwhile, we come to the conclusion in the Knx community that ETS is one of the most important pillars of the system. And Knx Rf, of course, should be supported by ETS. For this, we had some adaptations, not in the medium, but in the communication mode of Knx Rf to be in line now in ETS with the pair or as well with IP. So you have a smooth integration of wireless technology and also in a wired Knx network. And since 2014, now this new flavor of Knx Rf is fully integrated into ETS. This was done in the context of ETS 5, but of course now it's also fully available in ETS 6. And one very important issue was missing, as Mr. Arias already mentioned. It was the communication by using Knx security. Now, with Knx data security, the complete installation can be protected against bad people. And of course, this is very important for open media. And now we see as a consequence a growing number of products and of course also a growing number of manufacturers supporting Knx Rf together with ETS software. Now, what can you do with Knx Rf? Yeah, it's very easy. You can do more or less the same as you could do with Knx Twisted Pair. You can implement sensors, actuators, remote control, or what else devices you can imagine to control a building automation system, but now, of course, in a wireless solution. For wireless communication in building, of course, most people think about the renovation market, which is very important. So in Germany, in Europe, a lot of buildings has to be renewed in the next years, and not always a Knx cable can be installed. So Knx Rf gives a lot of new opportunities to use Knx in existing buildings. But also Knx Rf is can be used for new buildings, not maybe to implement a complete new building in Rf. I'm not in favor of just using Rf, but if you have a Knx installation, always there are some locations where you cannot install a twisted pair cable or it's simply not done. For example, in the area of a window where you have many glass, so you cannot use a cable, or simply you change the furniture in a building, so maybe you want to install a light switch somewhere else. In this requirement, Knx Rf is a very good solution, and you have a solution which is fully integrated. Of course, also in the past, you can use third-party RF systems to connect to Knx, but now it's fully integrated in ETS. You have for all devices, doesn't matter whether twisted pair or wireless, you have the same addressing scheme, the same group addresses, the same look and feel, and all the debugging is much easier compared to a mixed installation. Yes, a few words about our Knx Rf technology. It's located in the ISM band, so we are in the location of 868 megahertz. And Knx is using an FSK modulation, which is quite robust. This gives a very good range within buildings. It's very reliable, and always the question, is Knx a mesh network? No, it isn't. But the good news is for this frequency, mesh networking is not really required. So Knx Rf is, due to the sub-gigahertz band, very robust. Retransmitter are possible, as Jesus already told us, but typically they are not required. Indeed, what you can see later on, instead of installing retransmitters, I would recommend to use additional RF domains. Also, maybe good news for the manufacturers, for Knx Rf, you do not need a dedicated Knx transceivers. So most of the available ISM transceiver for the ISM band can be used to communicate with Knx Rf. This also is good news for low-cost production of Knx Rf products. So how is the Knx Rf technology working? Yeah, the idea is to use the same mechanisms as we have on twisted pair, and that's why also the telegram is very similar to this what we have on twisted pair. The blocking is a bit different. Here you can see an example. So we have in Knx Rf several block of data. It started in the beginning with some kind of pre-header, which is required to do some synchronization. In the block 2, you find more or less our classical Knx twisted pair telegram. If it is longer than 16 byte, additional blocks may follow. In the block 1, we have an extension where we put in information which is required to do the wireless communication, and most of the data in this first block is the serial number or the domain address of the used domain. You can also see there are several checksums, not only one, because in Knx Rf we have more disturbances, and each data block has an individual CRC checksum. Also, addressing mode has been reused from twisted pair. So as you maybe all know, in Knx we have the individual addressing, which ETS is using to do a download into a dedicated device. For runtime communication, we have the group addressing, and broadcast is used just for devices which have not yet an individual address. So to assign the individual address or physical address of the device. Now in Knx Rf, we have in the table 2 additional addressing modes. The first one, what you see, is extended group addresses, but this is just used in the push button mode. We do not use this mode together with ETS. But what's important is a system broadcast. As you heard, in Knx Rf, we have domains. This is used to separate 2 different installations. So in your installation from neighbors. But if you install a new device to your installation, of course, it's not yet part of your domain. That's why we need a service which has the possibility to pass through the borders of domains, as this we call a system broadcast. This we have in Knx for all open media. And of course, Knx Rf now is very strongly linked to the ETS, ETS5 and ETS6. And for all which are who have not yet used Knx Rf, what's new? Now we have lines for ETS. So what we had in the past for Knx TP, so twisted pair lines. Now we have also lines for RF. On the top of such a line, typically we have the media coupler, which is doing more or less the same as a line coupler, but now to connect an RF line. And each RF line has a dedicated domain address. And with this domain address, we create the RF domain. So if you have 2 RF domains in a building, maybe one at the first floor and a second one at the second floor, they have different domains, and they should not interfere each other. If they want to talk to each other, it will be done via the twisted pair backbone. The connection between ETS and Knx Rf devices can be done via a USB to RF interface, typically a USB stick, or it can also be done via a RF to twisted pair coupler. So in this case, ETS can be connected to a classical USB interface, which connects to Knx twisted pair, and the telegram will be passed to RF via the RF to TP media coupler. And what is the real good news? A lot of things are unchanged. So in Knx Rf, we use the same kind of Knx group objects. We use the same addresses. So address on twisted pair is the same on RF. We have the same look and feel for parameters, and also the download. Everything is pretty the same. So if you know to work with Knx twisted pair installations, you might need 15 minutes to understand what's new for Knx Rf. and you can use Knx Rf devices perfectly to your projects. So, as you know, in Knx, the group objects, they are linked via group addresses and they're configured by the communication flags. And this is completely unchanged in Knx Rf. And by the way, this is also possible for IP devices. So Knx now is a real a great solution. We have 3 media, IP, twisted pair, and RF, all with the same communication modes and the same look and feel. Parameters to configure a device. The parameters are, of course, manufacturer specific, dependent on the device which you're using. And finally, the download can be done simple via the complete Knx network, also via the full topology which you may have with different lines. You can connect ETS via the RF USB interface, or as I already mentioned, via the twisted pair and the media coupler. And in addition, also some devices may have a local USB connection to do the download directly in a very fast way. So let's have a look at topology. So the simple thing what you can do in Knx Rf is just to link 2 devices. So as a minimal to have an RF installation or an RF only installation is to connect a sensor to an actuator, and to connect ETS via USB with installation, of course, you need some kind of interface, an USB interface, for example, but this is only used for commissioning. Afterwards, the sensor can talk directly to the actuator without any interface or without any central devices. If you have a pushback button, which maybe also supports a USB connection, it can also be used to commission the system without additional USB stick. Maybe the more typical use case for Knx is together with a twisted pair installation. Here we have an example. On the left-hand side, we have a Knx twisted pair line with a power supply and a couple of devices. And the blue part is a media coupler from twisted pair to Knx Rf. And we have a second line which may integrate up to 255 Knx Rf domains, devices. In this example, all devices in the same domain. But of course, the solution can be much more complex. Here, an example with maybe a full-fledged installation. So you have a couple of lines for twisted pair and a few domains for Knx Rf. And the backbone may even be implemented in Knx twisted pair. And this is really a very high benefit of the Knx standard. We can have all this different media. We can integrate devices from as many different manufacturers as you like, and nevertheless, the complete installation is just one project. We have one addressing scheme, you have one address area for all these devices, and can all be integrated in one ETS project with one closed database. Some further aspects about Knx Wireless. As Mr. Arias already mentioned, we also have the so-called semi-bidirectional devices. What does it mean? So the device itself is able to communicate fully bidirectional, but in runtime mode, we simply switch off the receiver just to save our battery lifetime. So typical battery-driven sensors are semi-directional devices in Knx. They are just bidirectional for the commissioning. So ETS, when ETS is doing the download, there's of course a lot of interaction between the ETS and the devices. And therefore the devices stay for a couple of seconds in bidirectional mode, but afterwards they go into sleep mode and they act unidirectional during runtime. What now is new is the so-called segment coupler, already mentioned by users. Now you can extend each twisted pair line with the RF to TP coupler. The main benefit is now you can extend each TP line. In the past, you had to connect the media coupler to the area coupler, and now you can place the media coupler wherever you have a twisted pair connection. And also new in ETS and now coming up also in media coupler product is the so-called secure proxy. The intention is to connect secure and unsecure segments. Here there is an example. You have two lines on Knx twisted pair and one line or domain in Knx Rf. And in Knx Rf, of course, it's much more important to be secure compared to the twisted lines, which maybe is installed somewhere in the walls. But now, how to connect such secure push buttons to maybe unsecure actuators, which are still used in the market. And here the solution is a so-called segment coupler. So the media coupler has an additional job now. He's doing the translation from secure Knx Rf telegrams to unsecure Knx twisted pair telegrams and vice versa. And this solution is very flexible. So this mechanism can be configured address by address. So maybe secure to secure, unsecure to secure, and secure to unsecure. So all the combinations are possible to combine secure Knx technology with existing installations and existing products. Oh, here, see, it's in preparation for ETS. That's wrong. I didn't update this slide. It's in ETS 6. I'm very sorry for this mistake. Because the importance of Knx security, some words about this, because I am pretty sure Knx security will be very important in the future, not only for open media, also for twisted pair. It will be very important to secure our installations against bad people, which are definitely also in our life. The Knx security standard is based on standard security technologies. The main technology pillar is Advanced Encryption Standard, AES. Here we're using a block and key length of 128 bits. The challenge was to use these well-known procedures for Knx system. For example, in Knx, we have this group addressing, which is quite special for Knx, and it was really a challenge to solve all these requirements in the Knx standard, but now it's done. And in my point of view, it's really done in a very good way. And we have not only Knx security in the specification, we have it now also in ETS. We have it meanwhile in many products, and of course also in the manufacturers implemented in the test scheme and also in the certification scheme. Knx security is fully implemented. Just a few words how it's done. So in the classical Knx telegram, we always have this APCI, Application Protocol Control Information, which is an ID for the service like group value write or memory read, what we want to do with this telegram. And of course, this data, and especially the data behind, has to be protected. And that's why the APCI is replaced by only one APCI, which we call the secure APCI. Then we added a field, secure control field, with some flags for additional information, a sequence number for all telegrams, and then the rest of the original data will follow, but now encrypted. So a third party cannot read this data. And finally, followed by the message authentication code to be sure that the telegram is sent really by our trusted partner. To do security, of course, you need keys, and because of the quite complex system structure what we have in Knx, we do not only have one key, we have several keys. Maybe you've already seen, if you use a Knx secure device, you find now a QR code on all secure devices, and this QR code holds, we call this the device certificate, which you can scan with ETS. Afterwards, ETS shows you what's in, so the device certificates just holds the serial number of the device together with a FDSK, factory default setup key, which is required to do Knx commissioning of the network already from the beginning in a secure way. So even if a third party can listen to the download which doing the device, also the first download when it touches the device the first time is already secured. Nevertheless, somebody may know this key, maybe somebody took a photo of the device, of the box where you can find the FDSK. That's why the FDSK is only active at the beginning, and ETS replaces the FDSK by a so-called tool key. Although the tool key, we do not only have one for the installation, we have one for each device. So even if one device might be compromised, the rest of the system is still protected. Only if the installer makes a master reset on the device, the tool key is erased and the FDSK is reactivated. For runtime communication, we have in Knx the group telegrams, and for the group telegrams, we have the group keys. And here the same, not only one key for the whole installation, we have dedicated keys for each single group. This, of course, is a lot of information, and this information also has to be stored in each Knx device. So the complexity of Knx devices increases. And finally, to do secure communication, you need some kind of counter. So each device has a sending counter, and all receiving devices have to check whether the telegram is a fresh telegram or simply a replay attack using an old telegram from the past. To be secure also after power down, it's very important that for the sending counter and of course also for the receiving counter, the counterpart, we need persistency in all devices, which is important of course for device development. Knx security, as well of course as Knx Rf, is fully integrated now in ETS. It has been already integrated in the versions of ETS 5. ETS is also able to scan the QR code using maybe a webcam. If you really work with Knx security many times, I strongly recommend to use some kind of scanner to be used manually. And ETS is of course able to do the complete commissioning in a secure way, and also of course the download in a secure way. So this was an introduction about Knx Rf technology and some words about Knx security. Now let's talk about implementation of Knx Rf. Some words about Knx development. In our company, we're doing Knx development and especially Knx system development now for about or more than 20 years. And we have two main offers which we give to manufacturers who want to have connectivity for their new products. We have on the one hand Knx modules. In our company, we call them the BIOS modules. What it means, I show you later on. It's some kind of Knx stack on hardware. And of course, we offer the Knx stack in software, the Knx stack NGS, which is can be used for full integration and this is also very scalable. And as already mentioned, development is not only the matter of sources and modules what you need, you also need tools. We're doing a lot of development for tools implementation in relation with our modules and stack, and we offer services. On the one hand, we have development services for our customers, and we also have the Knx test lab to finally check whether everything is compliant. So bus access and object server, this is our BIOS solution. Now we have this solution since nearly 15 years. And meanwhile, the BIOS family has grown. It's not only modules, we also have a couple of devices which supports the BIOS protocol. But what is it? On the one hand, it's the bus access. This means we just pass through the telegrams from the bus. This is the same what each USB or IP interface is doing. And this can also be used as a programming interface with ETS. The more important part from our use case is the so-called object server. Here, the communication with the host is not on telegram level, but it's on object level, on communication or group object level. And this allows a fast integration of non-Knx devices into a Knx network. As a host interface, we support serial USB as well as IP. What you can see here now in the pictures, we have the classical module which support a serial communication with the host. We have USB devices which supports also the BIOS protocol and also our well-known Knx IP BIOS devices which are doing the same on IP level. Application areas for modules is always a question, is it a good solution to use a Knx module? And a module is always a very good solution if you have low and medium quantities. And it's also a good idea if you want to extend an existing device with Knx connectivity. Think about an existing device may have a high number or high volume of code, which should be combined with an existing stack and software. This can be a challenge. If you put the Knx complexity out of the device as an external stack, so the impact to the application is reduced. So as a couple of benefits, you have, of course, a fast time to market because the development effort is quite low when using modules. It has a low impact to the application. You do not need so many code and functions and resources to interface to an external module. You have very low investment. Nevertheless, you receive a certified system software for Knx. And of course, using a module, you can implement full value Knx devices. So you will have full ETS support. For the beginning, you can use our generic database, which provides 1,000 data points, which can freely be used. But of course, it's also possible to implement your own individual ETS entry. Here you can see all our BIOS devices. On the one hand, they support an interface on telegrams, which means we connect to data link layer. But if you're really using the BIOS protocol, we connect to communication objects. And here you see, if you talk to communication objects, the full Knx stack in the module is active, while when talking to telegram, the upper layers of the stack will be disabled. Yes, talking to telegrams is not the main topic today, but it's possible. Here is an example of twisted pair, but for Knx Rf, it looks pretty the same. Here with the telegram interface, you can send and receive Knx telegrams. and the coding of the telegrams always is common EMI as it is defined in the Kinex standard. On serial communication, we embed this in an FT102 frame, which is also quite common in Kinex. Yes, let's talk about the BIOS protocol. Here we talk to the communication objects, and this gives some kind of abstraction. So it separates the Kinex handling from the client. So the client just communicates with the BIOS module with the BIOS protocol. The client has no need to send or to receive Kinex telegrams. Also, the complete addressing, individual address or group addressing is not visible to the client. In the BIOS data, we have, of course, access to the values of the group objects. We have the parameters, which have been programmed by ETS, and we have the so-called server items, which are some internal properties which are related to the BIOS module. So again, the advantage of the object server, the host has not to deal with Kinex telegrams, and the module is also able to keep the current values. That means there's some kind of storage for each group object, and even if the application is sleeping, the module can put into memory the most recent values, and after startup, it's not required to send a group value read to the bus or to the RF network. You just ask the module what is the current state of the value. This also gives you short latencies in the system. And what's of course very important, the complete ETS download is handled by the BIOS module or BIOS device. It is not visible to the client. So you have a perfect decoupling from the user application, from the complexity of our Kinex network. Let's have a look at the hardware side of Knx Rf modules. Here we have the Knx BIOS module 840. Of course, when dealing with Knx Rf, the device cannot be powered by the bus or by the network. So typically the application is responsible to power the module. And on the module, you will find the microcontroller with our pre-programmed firmware implementing the Kinex stack as well as the BIOS server. And there's also the Knx Rf transceiver and the antenna output. And for getting started, we also provide a development board where there's an additional microcontroller for the application and also a USB connection with a virtual COM port and some IOs. And of course, there's also some demo code for getting started. So the firmware on the module, of course, the certified Kinex stack. And very important, if you use these modules in your product, you inherit the certification of the stack. That means the stack, of course, need not be certified again. Still, of course, your application part needs to be certified. Then we have the BIOS server, the BIOS protocol, including the bus access and of course the object server data. And for serial modules, all these telegrams are embedded in the FT102 frame format, which is a universal frame format already used in Kinex in another context. It has not been invented by Kinex. It's an IEC standard, and it was well tried, for example, in former BCUs for Kinex. So now let's have a look to the Knx protocol. We have a strict request response architecture. So always the host is asking for something and the module replies. But in addition, we have also indications to have a low latency and that the host not always has to ask whether there's something new. So we have access to the group objects, where we have services like group data point value, get data point value request, and there will be the corresponding response. To send a value, we have set data point value request and a response, and we have the data point value indication. To fetch the parameter values which have been programmed by ETS, we have the get parameter byte request with a corresponding response. Here you see some coding examples, but it's very simple. The complete protocol specification is available public for free on our webpage, and there's also a free BIOS SDK which you might use for your first implementation. So again, access to communication object and access to ETS parameters. For getting started, here you see our development board. On the development board, there is a Cortex M0 Micro from Atmel Microchip. We provide a free demo code, which is prepared for the Atmel Studio, which we have selected because this studio is completely free. And here you receive some kind of framework for your Kinex devices. It's the handling of the BIOS protocol is implemented, and a simple demo application which uses the push buttons and the LEDs on the right-hand side of this picture. So the code which you receive is of course prepared for this micro which is on board. The Atmel Studio uses the GCC compiler, but nevertheless you can use this code and port it to any other micro or any other compiler. The main things what you have to port is the usage of the UART and the timer. So for a skilled developer, it should not be a big issue. Here some examples of the demo code. For example, changing and sending a data point value. And here you see the response of a data point change. And here you see a handler for the data point value indication. So everything is already prepared, so you just can implement now what you want to do in the case of a value change. To integrate your product into ETS, we provide a generic ETS database for a quick start. As mentioned, this database provides you 1000 data points. Each data point can be configured using the corresponding data point type, and you can give it a name. But of course, this is just for getting started. But for a real product, we strongly recommend to implement your individual ETS database. In this case, for example, the data points have real names, not only 1, 2, 3. And the data point types are typically fixed. This you can implement on your own using the Kinex manufacturer tool. If you are not familiar with the tool, or maybe it's the only device you want to implement, we can also offer this task as a service from our company. For getting started, we also provide free tools. Here we have the NetNode, which is a bus monitor program, and there's a free edition. It has a multi-port architecture, so you can connect to USB, IP, and serial. And of course, you can connect directly to all Kinex media. In addition, it connects also to the BIOS protocol, and you can use both telegrams as well as Kinex telegrams, as BIOS telegrams directly in the view, and you can also send all requests with NetNode, the free edition. Here our solutions for Knx Rf. On the one hand side, we have the Knx BIOS modules 840 Rf with a host interface on serial FT1.2, and this is typically used if you want to extend, I would say maybe small devices with Knx Rf. In addition, you may also use our Knx USB stick 340. It's a normal USB stick which you can use as programming interface for ETS. It has a host interface with USB HID as specified in the Knx standard. But this stick also supports in addition our Knx BIOS protocol. This means you can use this stick as some kind of external Knx Rf stack for devices with an operating system like Linux. So if you have maybe a boiler or a heating system which running as a control system running on Linux and typically has a USB connection, you just connect the stick 340 and you can integrate or add an ETS entry for your device, and your device is fully Knx connected with ETS support and also can be certified without touching the hardware of your device. Next to the BIOS modules, of course, we also offer our Knx stack. The question is, when is a Knx stack recommended compared to modules? A stack is typically recommended if you have very high volume. There is not a fixed figure, but if you produce thousands of devices per year, maybe a full integration with a stack is more attractive from cost point of view. It's also more attractive if you have many devices we want to implement, because here it makes sense to really train your team to invest in technology. If you have just one, it's really critical whether it makes sense to do all this investment to implement just one device. The benefits of using a Knx stack is the high flexibility and finally the reduced costs for production. But nevertheless, take into account the high investment, not only for stack license, but also in training of the team, learning how to work with a stack. So it's really not maybe recommended for the first try of Knx development. And of course, you need skilled developers who really know how to deal with complex embedded software. Here you can see an overview of our Knx stack NGS. It's a professional solutions for high volume products. It's intended for 32-bit micros. So indeed, currently more or less we just support Cortex-M micros from different manufacturers. We have Knx security fully integrated, and the stack is modular. So with the same code basis, we support Knx twisted pair as well as RF and IP, Knx IP only devices. And also the code is scalable. So we have a compact editions for reduced complexity and the plus edition with more or less unlimited resources as far as possible concerning the Knx standard. We also provide development hardware and of course tools, a dedicated version of NetNode for our stack customers. Here you see an overview of our modular development board. So it doesn't matter what flavor you want to use. We always have the same baseboard. On the baseboard, we have pigwags for the micros. Today, mainly 32-bit micros, but in the past also 8-bit or 16-bit micros. We have bus access. On the left-hand side, in the middle, you can see a bus access for Knx twisted pair. On the bottom, there's a bus access for Knx Rf. On the bottom, on the right-hand side, this is an extension for Knx IP. For Knx Rf, we provide a corresponding medium access pack. It integrates a data link layer for a dedicated ISM transceiver and also all the drivers, SPI driver, and all what you need to talk to Knx Rf. For hardware connection, it's not very complex. Of course, you have to follow the instructions from the datasheet of your RF transceiver. Of course, you have to add to the microcontroller clock and etc. The connection between the micro and the transceiver typically have two parts. One is a configuration interface, which is typically some kind of 4-wire or SPI interface, and typically the microcontroller is a master, and you have the data interface, which is the bit stream which you receive from Knx Rf, from the RF medium. Here you also typically have an SPI interface, and here the clock is generated typically by the clock recovery of the transceiver, so the microcontroller is slave. And of course, you have to add your application specific parts, push buttons, LED, relays, whatever you like to implement. Here's a selection of ISM transceivers we have already used in development. Currently, quite popular is the last one, the S2LP from ST. Also today in the session. And we also have implemented corresponding RF modules which are compatible with our development solutions and may also be used for products. The antenna can be soldered on the edge of the module. Typically you have just a wire antenna, but don't forget, also if you're using a module, you have to care about antenna matching. So if you integrate an RF module into a device, an enclosure, antenna matching might be needed to be changed. Some background information about sending and receiving. Sending is quite simple, as always. Sending is just straightforward. You send the pre-header, do the Manchester coding of your telegram, and just send it out. Receiving is a bit more complex or a bit more stress for the micro because the transceiver runs in NRZ mode and you receive the data not synchronized. And on RF, it's not like twisted pair. If the twisted pair line is quiet, you receive nothing and it starts with a telegram. In RF, it starts with noise and you really have to find the start of the telegram with permanent sampling. And if you sample a chip rate of 32 kilo chip per second, you will receive 4,000 patterns, each 8 bit per second. And you really have to scan all this to find the start of the telegram. And if you found it, you have to do the Manchester decoding. But all this code is implemented in our Knx stack, and you do not really have to take care about. So this is an overview of the architecture of the lower layers. On the bottom, you see the RF transceiver with a programming interface as well with a data interface. Both are connected to a corresponding driver in the firmware. Here it's a SPI driver, depends on the type of transceiver. And we have a platform interface. PFI is a platform interface for Knx Rf front end. And then it goes to Knx Rf PL, which is some kind of physical layer, but of course the real physical layer is implemented in the transceiver, but it's the interface to do everything what is physical layer related and not part of the link layer. And as soon as we really have complete bytes, we pass the data to the link layer, and link layer is able to compile complete Knx telegrams and vice versa. So link layer is responsible for the complete block building and the checksum. And the rest is done by the Knx Rf PL module. But the good news is, as soon as you have complete Knx Rf telegram, you can pass these telegrams to the normal Knx stack. It's the same code base as we are using for twisted pair and IP. And most of the modules can simply be reused unchanged. Of course, there are some extensions which are required for Knx Rf. Like here, you have some additional services to handle the domain aspect, which has to be added if you compile a Knx stack for the RF medium. Again, the topic of Knx development tools. So note there is a professional version to work with a Knx stack. There's also a tool we call Traceman, which gives you an optimized debug support with some features which cannot be done with a standard debugger. And very important, we have this tool KScript, which is a model-driven approach to do a model-driven design based on a scripting language. So all what you need in ETS, of course, you need in parallel to handle in the firmware. That's why we can write down the structure of your application in a Python syntax, and we can create in an automated way the complete ETS product entry. This integrates the static part as well as the complete dynamic part and also the translations. In parallel, we create a couple of include files which holds all the addresses and names of parameters, group objects, and so on. K-Drive SDK is a cross-platform SDK which you can use to implement your own tools on Windows or on Linux. The intention is to give you bus access, but also integrates client services. And there's also a free version which you can find on our webpage. And of course, there's also a commercial version. And meanwhile, also K-Drive SDK supports Knx security, which means Knx IP security as well as Knx data security. So this is already the conclusion. In my point of view, Knx Rf is really good news because it's now fully integrated into the Knx system. We have ETS, one tool fits all. We have the potential to use Knx Rf in the renovation market, but also in complex topologies. And very important, the step to Knx data security really enables new applications, new opportunities to the market. And the technology is available. Everything is there, specification, ETS, EIT test tool, test lab, and also for the developers, Knx Stacks a module and development tools. Everything is available. Just do it. Okay, thank you very much. Now we have 5 minutes time. I can just give you a very short demo using NetNode. That's why I kill now my slides and try to show you NetNode. Now you should see our bus monitor NetNode. Maybe just change a bit the size. Okay. And what is already connected is, maybe you don't know if you can see it. One moment. Yes. This is a development board for Knx BIOS modules. You can use it for twisted pair as well as for RF. Now you see with antenna, there's an RF module connected. I connect it to USB because I need some power. And I have a Knx wireless push button. And if I go here, I have the BIOS view. I can read, oops, maybe I should rescan. Open the BIOS view. I can read the server items. Now I'm connected directly to the module. And after scanning the module, I found a couple of data points which I have programmed with ETS in advance to speed up. And if I now press the button, you will see here the change of data. And there's also one, maybe I can show it. There's also a counter. You can see it increases every time. Here you can see it when I press the button. And you can see here also the communication. It is the BIOS communication. Here I receive always a data point value indication. But now, in addition, I can also open a USB interface. No, there is an error. Maybe I crash something. Yeah. It's always the topic. If you want to show something. Here we are again. BIOS view. So you again start with indications 5, 6, and so on. And now I have opened not only the BIOS connection, but also a USB connection via the telecom level. So I see here the data point value indication, but from the USB stick, I also see the L data indication. And now I can also add another BIOS view, select the USB, and now I have the same BIOS server on USB. So if you like it, just try it out. The net node is for free, and you only need maybe a development board or USB stick to test the BIOS architecture. Okay, thank you very much. Now we are at the end, just in time.
Thank you very much, Mr. Vancil. Thank you for the comprehensive presentation, and even with a live demo at the end, which is really nice seeing it after the theory and the explanations, how the actual development platform works. Just one question for you. Normally, I get this question from manufacturers. How hard is for those manufacturers who are used to develop only twisted pair devices to add Knx Rf into their production line? In your view, how hard is for a manufacturer to do this transition?
We did this several times, and I would say the transition is not very critical. We also have had manufacturers who started from scratch with Knx, Knx Rf, and I would say to start with Knx in general is a higher challenge than to go from Knx twisted pair to Knx Rf. So the system behind the stack, ETS, everything is the same. You just need to add some RF technology. And of course, we support our companies to go to Knx Rf. We recommend maybe also some test equipment. And of course, there are also some third-party consultancy which can be used for antenna topics and all these things.
Of course, yes. Thank you very much. I do appreciate also you used your exact 1 hour, so thanks a lot. Now we are gonna switch to the next presenter. We had a bit of an issue with their actual feeding the streaming into this platform. So we found a workaround to make it happen. I asked all the participants to switch to stage number 2. So you can go to your left screen, click stage, and go to second stage. You will find now 2 options. Go to second stage, and Philippe from ST Microelectronics will be there broadcasting in the next minute or 2. So please switch to the stage number 2. Thanks a lot.